So I'm Yoshi, I'm a data engineer and consultant. We work in a Belgium-based company, Element 61. So yeah, let's get looking at the agenda. So what we'll be tackling today, first of all, we'll talk about the evolution to a lakehouse. We've heard about this story already a bit, but it's still quite valid for our presentation, so I'll go into that a bit myself as well. And then we'll be talking about why are we automating data warehouse development, why is it relevant? We'll dive into the Spark framework that we built, a bit more technical parts there, and we'll also be standing still a bit with DevOps that we can do, and also some bridges we can make between BI and other modern use cases. So, evolution of data architectures. Generally, we had the data warehouse, and the data warehouse actually is a pretty neat thing, especially in the past. Used all over the place. All of your data can be centralized from all different sources. Your data is very structured, and it's just a great thing to work with. Everything's going quite smoothly. You can run your SQL queries on it. But over time, it just got a bit limited. So still for the use cases, as a data warehouse, it's still fine. But if you want to do something else, it's just not possible. You don't have the variety of data. You can just not work with JSON. You cannot work with unstructured formats. So that just makes it all a bit more tricky to use. So then we had the introduction of the data lake, which was really great. That one, of course, has no limits. Basically, it's kind of a folder structure kind of type of storage, which makes it both support structured, unstructured data. It can have all different kinds of files. Where, for example, Parquet is a file that got introduced, which is works quite well to use in a big data sense. And the storage cost is also just quite low, which is quite nice as well, as we're entering this era where just data is getting bigger. So even though this data lake is quite nice, there's still some challenges that we have here. For example, metadata management is something that's not really available out of the box. Another problem is data versioning. Sometimes it could be nice to just be able to go back a month or a year in your data just to have the state at that time, which is also a bit trickier in a data lake. Real-time support is also something that's lacking. If you're talking about some streaming use cases, that's also something that generally is not available just in the data lake itself. Also, the quality could be a bit trickier to do. You could have some corrupted Parquet files if you're writing to within a data lake. So all of these things are a bit unideal. And then especially if we're looking at what you want to have if you're talking about a data warehouse, and you talk about modifying existing data, appending new data, updating rows, and especially for your data warehouse, if you're running SQL queries on your data warehouse, you want that stuff to go really fast. And in the past, on the data lake, that just was not achievable yet to do that in a fast way. So currently we have the data lakehouse, and this has been talked about quite a lot. I would say it's the main theme of this conference, but I think it's generally just a really good concept. So we're still using the data lake as the base for all of our data, but we're just solving a bit of the challenges that I've just mentioned before with some new tools and some new ways of working. For example, one thing that got introduced, this is in the Databricks sense then, is Delta, which is just a great extension on the Parquet format, which allows for streaming, allows for ACID transactions, which we'll get back on later, and just allows for a better format where you can also have some metadata management. What as well is the case is that there's been some optimized performance, and especially recently, if we look at yesterday in the keynotes, we got some announcements on Photon, which went GA yesterday, or is close to GA. So those kind of things make it all, again, more interesting to just talk about the data lake also as a warehouse. In this data lakehouse, we can do machine learning and BI together, which is, of course, also a nice plus. And we're also, we see these tools, governance, security being added. It's still a bit early, I would say. There's a lot of providers, I would say, that, a lot of companies who are trying to get into this. And Databricks has its own product. They're GAing in, I think, 6 to 8 weeks, Unity catalog. So it's pretty exciting there, but still a bit new. So we're still, probably have some growing pains there. But what's really nice about the Lakehouse is you have just no limits on file. tools, but especially also languages. If you're talking about Python, Spark, if you're talking about SQL, if you're talking about Scala, if you're talking about even about R, like everything is possible, and that just introduces a lot more people to the data lakehouse and also the data, like the warehouse and the lake from the past. So why do we actually want to run our data warehouse workloads in a lakehouse? Well, actually, it's just really neat that we can have all the data in the same place, because the data that a BI engineer will use to get some queries, generally it will be the same data that a data engineer or a machine learning engineer or a data scientist will use as well. And some data will only be used by the BI, some data will only be used by the machine learning engineer, but still, like, generally it's all data. And it's just nice to have everything together in one lake. And even if some case is not in the warehouse now, we can add it later, and similarly for machine learning use cases. So that's why we want to do that, but then why do we actually want to automate the development? And then, of course, automation is nice in any way, but we'll just go a bit to why we want to do that. Actually, if you look at the things that, if you want to look at how to build a warehouse from in a lake, the things you will need there. First of all, we will need to read in some tables. We will need to read data from bronze. The data will be ingested via some other product. But then from bronze, we'll need to read in the data, make sure the schemas are correct. And then we'll go on to the next steps for the data warehouse, which is, first of all, we're creating the dimensions. So we're creating incremental integer keys, also some dummy primary keys when there's missing records. And we need to make sure that if new entries come in, these keys get incrementally updated. So the key always increases. And then to actually make sure that everything runs smoothly, we have to do an upsert into gold. That's for the dimensions. For the facts, it's like a bit similar because we'll also do the upserts into gold, but there we also have to do the lookup. We have to make sure that we link a certain fact that we have, that we link it back to a certain dimension table. But actually, there's actually a lot of tables possible. So you can have so many incoming source tables. You can also have so many dimension tables, and you can also have a lot of fact tables. And that just increases like the need for making something that you can actually speed up this process. You don't want to do all of these steps separately for each table. You want to really speed this up. And that's why it just makes sense to get this more into a framework style, make everything reusable, and just properly orchestrated as well. And then I will give the word to Ivana.
Thank you. All right, so let's see how the Spark framework that we have built for modernizing and automating the data warehouse looks in a lakehouse environment. So first we start by ingesting the data from the different data sources. Typically for that we use Data Factory to just load the data either from on-prem or somewhere in the cloud. And we put the data in the bronze layer in the raw format as it is. From here on, we start with the framework. As Yoshi mentioned, we have to read a lot of different tables. Some of those tables are loaded fully, some of them incrementally. They're coming from different type of data sources, and it would be difficult or like really time extensive to read all these tables separately, which is why we created some functions that can dynamically read this data, create data frames, create views, depending then if people want to use this data in a SQL manner or they want to use just Python, depending on their skills. Then the business logic needs to be created. This is the manual step that the users need to do. So they have to here create the queries, which are going to combine their data into facts and into dimension tables. Which then we are going to stage in the silver layer of our data lake. And we are going to do that, and we're going to store it in a Delta format. A lot of the data warehouse principles are what goes between silver and the gold layer. So here we have to create all the surrogate keys for the dimensions, which are integers, and they have to be auto-incremental. For the fact tables, here we have to do the lookup of the foreign keys. We have to do that for SCD type 1 dimensions, but also for slowly changing dimensions. And all of this we have implemented into a framework which does that dynamically based on a naming convention. And all of that is written in Spark and is running on Azure Databricks. And basically in our gold layer at the end, we have our facts and dimensions with the relationships between the tables. So the user between silver and gold just has to define what's the relationship, and the functions are going to handle that. So they're going to automate all these data warehouse principles. But to have data warehouse principles implemented on data lakes, you need to have transactions. And that's where Delta comes in hand. So Delta brings ACID transactions. So it allows us to have the atomicity so that every transaction is going to be linked or logged into a transaction log. We have the consistency. So we have isolation on writes. We have concurrency, people can all write to the same table, and we have durability, so the data is available still also in case of failures. But for data warehousing, we know based on like the previous architectures, like when we had just structured data, the data is well governed. We need to have APIs which are always correct, so we need to have high quality data. And this is also something that Delta helps us achieve. So with the transaction log that Delta has, we can guarantee the atomicity. With Delta, we have the transactions, so now we can easily do deletes, updates, merge statements, which is something that is necessary if you want to do or implement some data warehouse principles on data lakes. And then we have the enforced schema, so we can be sure that the data doesn't change or that the data type didn't change in the meantime. And we can have identity columns, which we see later help us with the creation of the surrogate keys. So let's see some of these data warehouse principles. I'm going to talk a little bit about slowly changing dimensions here and how we can implement that using Delta. So here in the example, we have a customer table, which only has, in this example, 2 records, where the customer has as a city, Brussels and Antwerp. And all of these records are current records, so there is no history attached to them. But let's see what happens if we have a new update. One of the customers changed address, so the city changes, and now instead of Brussels, it's Antwerp. We have these hashed keys, which are just a hash of all the different columns, which allows us then to see if the row has changed or not. And at the end, we will have something like this. So we want to keep track of between which time this customer belonged to Brussels and then from which time it is in Antwerp. How do we do this? That is the first step here is to get the new data, the updates that we received, and join them with the current data that we have from the customer, where the current state is true and the hash key is different. So we want to just get the records which are different. In the second statement here, below, we do 2 things. We want to first select the customer ID and the updates. And this is what is going to be inserted when the clause is, when the condition is not matched in the merge statement. And we are going to union it with the updates. This is something that will be inserted, this will be something that will be updated in the merge statement. The merge statement looks like this. So we have the current customers, and we have the table, and we have the new updates. We will do the merge condition on the customer ID. So when this condition is met, we will update. So the end date will now become today, the current date. And isCurrent will become false. So the record where we had Brussels for the customer will become false, so it's not going to be the current record anymore. And when it's not matched, we will insert the new data, and now we will set the new records to have the flag isCurrent set to true. So this is one of the data warehouse principles and how we can do that using Delta and Spark. Another one I want to talk about is surrogate keys. There are two ways. So before some of the announcements on new features on Delta, we used to do it differently with monotonically increasing ID function. But this was not so easy. This function could sometimes generate numbers which are very high, and then the business doesn't like them. If we want to really generate incremental records like 1, 2, 3, 4, sometimes we had to do that in a serial way, so we could not really parallelize this. And also at the same time, we would always have to look in the current dimension table, see what is the maximum primary key that we have, and then start from there, which was quite an extensive procedure to do. But now, with some of the new announcements on Delta, we can do that with using the identity feature. So just when we are creating the Delta table, we can add this generated primary key always as identity, which starts from 0 and is always incremented by 1. With this, we don't have to generate these surrogate keys ourselves anymore. And then another one, foreign keys. So we want to create a relationship between our fact tables and our dimension tables. And we have to do this for both SCD type 1 and SCD type 2 dimensions. So here we are using joins, but we are also using for the SCD type 2 dimensions a range join optimization, because here it's not just joining it on one of the keys, but also we have to look at the validity of the dimension record between which periods it was valid. So how would this look like if we would put it in a flow? So first, for the dimensions, we will read first all the bronze tables that we need in order to create the dimensions and the facts. Then a user has to add an input, so they have to provide a query of how we want to create these dimension tables. Next step would be to stage this to the silver layer where we have our cleaned data. And next would be to promote it to gold, where we will have our actual dimension table. We have something similar for the fact tables as well. Here we are again reading the bronze data. Then user has to manually give an input query which will define one fact table. Then the cleaned data with the query, we are gonna stage that to the silver layer. Then the promotion to the gold layer, here will first have to get an input from the user again, which will define what is the relationship between each fact table and the necessary dimension tables. And only then we will do the promotion to the gold layer, again, where everything is stored in a Delta format. Let's zoom in a bit on each of these flows and what exactly is happening there. For reading the bronze data, so we want, as I said, we want to do that dynamically. We want to do that for both incrementally loaded tables and fully loaded tables. We can use an input like the table that we have on the screen, which lists all the tables that we have from all the different sources and if they're incremental or not. Based on this, we have a function which can read all these tables and can create then either a data frame or a SQL view, then depending on how you want to use it. Next, I mentioned that user needs to give manual input here. So we want to create the queries. That's something that we can't really automate. People have to really say what are the columns that they want. Do they want to join multiple tables together to get one dimension, like for example, the customer's dimension? And it would look something like this, like the statement we have on the screen, where we are selecting from the customer table the columns that we need. Where we are creating a business key and creating some other attributes like the customer name and the customer city. Once we have this query, we want to stage it to the silver layer. So here we are gonna dynamically create a hashed key, which is gonna be hash of the business key. We're gonna here enforce the schema. So we mentioned that we want to have high data quality in our Lakehouse. So we're gonna enforce the schema with delta. And we're gonna check if some of the data warehouse principles, for example, are met here. For example, that the business keys have to be unique and some other data quality checks like this before we could actually write it to the silver layer. With enforcing these checks, we ensure that we have a high data quality in our data lake. From the silver layer, promoting it to the gold layer, for these dimension tables, we have to create the surrogate keys. And this was done, as I mentioned, with the monotonically increasing ID function, or now with the identity feature. And then we want to merge this data. So because we want to be able to handle both full loads and incremental loads, we are going to merge this data based on dynamically created condition that was specified in the query. So that's the flow that we have for the dimensions. For the fact is similar, maybe a little bit more extensive. The first step is the same for both facts and dimensions. We have to read all our source tables. And then users have to provide, again, an input. They want to create maybe the orders fact or invoices fact. So they have to be able to join different tables maybe from the source together, specify the columns that they want. And then in the stage to the silver layer, we're again gonna create some hashed keys from the business keys, which are gonna help us later dynamically look up for the foreign keys. Then we're gonna write, when we're writing to silver, we're gonna enforce again the schema of the fact tables as well. And to ensure the data quality, again, we're gonna do some checks, like for example, as I mentioned, checking if the business key is making one row unique in this table. Then before we promote it to gold, the user has to again provide something manually, and that is to define what is going to be the relationship between the fact and the dimension tables. And that can look something like in the slide here, where the facts invoices is linked to the dimension customers. Just providing this kind of dictionary, we can use this in the next step when we are promoting to gold, where we are going to look up for the foreign keys. So for the fact invoices, we're going to look up the foreign key to the dimension customer and add it in the table. And again, because we want to handle full loads and incremental loads, we are using the merge from Delta to actually promote it to the gold layer. We want to be able to apply some of the DevOps principles for BI in a Lakehouse. We want to, that's the purpose of this framework, is to automate the data warehouse development. So whenever a new change is happening to some of these functions which are generating the code, we want to be able to test all that, everything to be part of a CI/CD pipeline so that everything is fully automated end-to-end. For that, we're using Azure DevOps. First, we have built a testing framework. So all of these functions, we have unit tests for them. We have integration tests also built. So whenever someone wants to change anything in these functions, we are going to run these tests, and we're going to build a coverage report to see what is the coverage of the tests for all of our functions. And then if all the tests have passed, we can then deploy our pipeline, so we can move to the next step of which is then the packaging. We want to create a package which can be used by multiple users, so they should all use the same version of the code that we have. So once we have tested all these functions, we're going to package all this and put it into artifacts, in the Azure artifacts in a private PyPy repository. And then users are able to install it in their Azure Databricks environment, either in a notebook-based scope, or they can directly install it on the cluster. So, as Yoshi already mentioned, one of the reasons why we want to do this BI development or this data warehouse development in a Lakehouse is to be able to be closer to the other teams, like data scientists, data engineers. So we want to be able to use the same environment for other use cases as well. So besides doing this BI, data warehousing, and SQL analytics, at the same platform, using the same data, we can do data science and machine learning. We can do some real-time analytics, all using the same data coming from our data lake, using the medallion architecture, using Delta. And then on top of this, we could start using any other tools like Power BI, Synapse, Azure Machine Learning Studio, Data Explorer, any other tools which can then connect to the data in your data lake, maybe for better user experience at the end. So to conclude here, the Lakehouse solves some of the shortcomings of data lakes and data warehouses. Using the Lakehouse, we are now able to automate and modernize the whole data warehouse experience or data warehouse development. And we can have one architecture which can handle the different workloads by the different teams, like data scientists, machine learning engineers, data engineers, etc. All right, thank you. And I think that leaves us about 6 minutes for questions.
I'm really curious. You closed with a statement on it solves some of the shortcomings. Now, which are the key things that you are still missing that you would really like to see?
Well, most of the shortcomings that all of the shortcomings that were listed on the slides before were already addressed with Delta Lake. Yeah. What are some of the other shortcomings? I think some, like the identity column that was just recently introduced, is one of the features that allows us to have better performance and do it in a better way. I think some of those new features that are coming to Delta help us or do this even in a better way.
Yeah, indeed. I think also the Unity catalog, which is quite new, is something that generally in data warehouse you have a quite nice overview and very structured, and that's something that's still like the Lakehouse will do that, but it's not fully there yet for the whole thing. But it's still already a very good setup.
Thanks.
Hi. This question is around near real-time analytics. I couldn't gauge if this was a batch or near real-time, but if we have to achieve near real-time, what would be the latency for us to visualize the latest events? So
to repeat the question, you want to know what is the latency and how often we can run this flow?
Yes. Was this a streaming pipeline or a batch?
Yeah.
And if streaming, what was the latency?
Yeah. So the first part, when we were reading from the bronze layer, that can be done, for example, using the autoloader feature from Databricks, which can then read either in streaming or just with the trigger once functionality, which is still the streaming, but just running it once a day or whenever you want to schedule it. So you can run it almost real time, or you can run it batch. You can do it both ways. Yeah, thanks for the question. So how do we handle late arriving data with our framework? It's a good question. It's not so easy, and so sometimes we have to rerun the flow again to go and do sometimes backfills once a day, for example. That's, I think, most of the time we're handling it like that, but there is not really a way that we have embedded in the framework that handles that.
Yeah, I think there's you could do some stuff with watermarking and stuff like that to try to do something like that, but we didn't really focus on it that much because we just were quite happy with the flow we had, and because it was quite easy to do sometimes a backfill, we didn't really mind scheduling it as such in our structure.
So my question is, why surrogate keys? Means you can just use natural keys to join your dimension and facts.
Yeah. We still want to keep these surrogate keys, some of the old data warehouse principles, because in some of the visualization tools, that still brings a lot better performance than just not having them or joining them on some string values, for example. For the end users, the visualization performance that still has a better performance.
Hello, just one question regarding the slowly changing dimension type 2. Are you considering all fields to put the hash key, or the framework has a kind of parameterization that you can select the fields that you want to control the versioning of the data?
Sorry, I didn't catch really the full question.
I would like to understand how you are controlling the slowly changing dimension in your framework. If you are generating the hash key for entire row, or you are considering all fields or not?
The hash key gets all the attributes and creates a hash of them, and then we check if the hash is different. That means that some of the attributes has changed. We have the possibility to specify in some of the functions to say on which attributes do you want to do the cache, because sometimes you don't want to have the slowly changing dimension on all of your attributes.
It's the point that I would like to understand.
Yeah,
okay.
that is an input of one of the functions.
Okay, thank you everyone. That concludes this session. Let's give a hand of applause to our speakers, Ivana Paheva and Yoshi Kokens.